Okay, this is the second video. The previous video we have discussed about SR latch. Now it is flip flop. Flip flops. Again, the subject is digital electronics and linear integrated circuits. The sequential circuits. Design of sequential circuits. What we are going to discuss in this video is RS flip flop. Yes. This is the circuit diagram shown here. It is RS flip-flop. As you already know that the difference between latch and flip-flop is in a latch there is no clock signal, whereas in the flip-flop there is a clock signal. Therefore, our digital devices, say example whatever may be the at present digital device, example, very good example is your cell phone. When we purchase a cell phone, the first what we do is nothing but we have to register the Gmail and we have to register the clock pulses. We have to start the clock pulses. Once the clock pulse is turned on, the timing is given, then whether there is a network or not, whether there is a supply or not, whether the battery is drained or not, whatever may be, until the death of a cell phone, the clock will run. Until the death of the cell phone, the clock will run. Therefore, for any digital devices, the clock pulse is very, very important. For our discussion, the clock pulse is acting as an enabling or disabling point. For our discussion, let me assume that when the clock is 1, which means it is enable, and when the clock is 0, which means it is disable. The circuit diagram for SR latch is shown here, which consists of 2 NOR gates, and 2 AND gate is connected, one for set, another one for reset input. And the second terminal of both the AND gate is given to the clock pulse, which is named as enable here. The clock depends on the clock pulse frequency. The circuit operates, and for our discussion, when clock is 1, which means it is enable. And the remaining truth table, it is almost similar to SR latch. This is the actual circuit diagram of an RS flip-flop, the clock and 4 NAND gates. Again, the feedback path is there. Therefore, Qn, the present state, comes into picture. And now let me see the operation of RS flip-flop in detail. Yes, this is the truth table of RS flip-flop. The another name for this truth table is also called the state table. Since why it is called a state table? Because the R and S, the input is there, and Qn is also comes into picture, which is nothing but your present state, and Qn plus 1, which is your output, which is your actual output. And see here, the clock is 0, which means it is disabled. Therefore, for our entire table, I have assumed clock as 1. Therefore, this entire truth table or an state table is in enable mode. Now see here, since there are 2 inputs, S and R, and Qn, another input, which is nothing but a feedback or a present input. Therefore, since there are 3 input, the possible combination is 8 for digital. Therefore, all the possible combination is written here, 000, 001, 010, and goes on. Now, let me assume that this is the assumption value. Now, what may be the output of RS flip-flop? The clock is in enable condition. See here, as per the RS or SR flip-flop, when both are 0, the comment is nothing but no change or hold. both are 0, the comment is nothing but no change or hold. Therefore, whatever may be the assumed value, this is the assumed value. This is S and R is 0, assumed value is 0. Assumed value is 0, then the output is also 0. Since it is no change. And assumed value is 1, the output is also 1, since it is no change. Right. And see here, for this, the second column, again S is 0 here and R is 1. R is 1, whatever may be the assumed value, the output is 0, reset. Since reset is 1, the output is 0. Therefore, 0, the present state is 0, the next state is also 0. And when present state is 1, the next state is also 0, since it is reset. And see this third column here, this is 1, which is nothing but S is 1. And when set is 1, the output is 1, whatever may be the assumed value. See, assumed value is 0, Qn is 0, therefore Qn plus 1 is 1. And Qn is 1 and Qn plus 1 is 1, which is nothing but set. And the last 4 columns, since S and R both are 0, for both are 0, the output Q and Q bar will remain same, whereas as per digital it is not accepted. Therefore, the assumed value is 0 or 1, whatever may be the assumed value, this input combination, S and R input combination, doesn't accept it. Therefore, it is a forbidden. It doesn't accept it, therefore it is an forbidden comment. It doesn't accept it. Okay. And this is the truth table of RS flip-flop. Now see here, the truth table on the characteristics table is elaborated here, where clock, see the first 2 lines, when clock is 0, whatever may be S and R, the comment is no change. Assumed value is 0, output is also 0. Assumed value is 1, output is also 1. And hope you understand this operation of an RS flip-flop. Thank you for patient listening.